Welcome to Learning to Engineer. I'm very sure that you would have watched these videos of OPAMP and you will have a fairly good idea of this device by this time. To be able to solve the problems, you need to know some basic concepts in network theory also, and then you can try to solve this problem on your own. So I highly recommend you to see the question, pause the video and then try it out by your own self and then continue watching this video. Let's get started. This is the first question. The breakdown voltage of the Zener diode is given as 3.2 volt and these are the value of the feedback resistance, and you have an input resistance of 1 kilo ohm. Then when you supply a voltage of plus 1 volt via this terminal, what will be the output at this end? That's the question. This will sound pretty straightforward when you don't have this Zener diode. This is a ideal Zener diode as given in the question, and you are given this breakdown voltage of a Zener diode. This is the voltage at which the reverse bias mode of Zener diode will start conducting to a very maximum level. At the breakdown voltage, there will be an avalanche phenomenon in that Zener diode, due to which the current will be extremely high and there is an extremely high flow of electrons from the P junction to the N junction, and as a result this will be the voltage across the open circuited, the breakdown terminals of this Zener diode. So the Zener diode conducts in the reverse bias. So between these two ends the voltage is 3.2 volt. That is what is the meaning of this breakdown voltage. So let us find out the output value of V naught. Let us find out the output voltage when the Vi is 1 volt. Let us formulate the KCL equations using this information. We note that there is no current flowing into the inverting and non-inverting terminals of an OPAMP, and because of this virtual ground concept, this is 0 volt, so this is also 0 volt, and as a result there is no voltage at this end, and whatever is the current that is entering via this 1 kilo ohm resistance splits into two divisions here and here. Okay, so having this flow of current in mind, we can write the KCL equations. By the Kirchhoff's current law, at this node Vi minus 0 divided by the resistance will be this current, right? Vi minus 0 divided by 1K, which is this path, this current is equal to the split up of these two currents, right? So Vi minus 0 by 1K is equal to 0 minus V naught divided by 10K, which is the current through this path, plus it's 0 minus 3.2 plus V naught divided by 10K. Because this is the breakdown voltage of Zener diode, the voltage at this end will be 3.2 plus V naught, and what is the current through this line? It's the difference in voltages divided by the resistance value. So the voltage at this end is 0 volt, at this end it is 3.2 plus V naught, and the current will be 0 minus 3.2 plus V naught divided by 10K. If we solve for this, we will be able to get the value of V naught. It's given that the value of Vi is 1 volt, so let's substitute, and yeah, we can cancel these terms here. So it will be 1 divided by 1. 1 is equal to minus V naught divided by 10 plus minus 3.2 minus V naught divided by 10. So we are taking this 10 to this side. So this implies that 10 plus 3.2 will be minus 2 V naught, and this implies that the value of V naught is equal to minus 13.2 divided by 2, which is equal to minus 6.6 volt. Okay, so this is the value of the voltage V naught. We just applied the value of Kirchhoff's current law, and having all these basic concepts in mind, we were able to solve this problem. We will solve another problem which is of the same type. and you are supplying a voltage of Vi and the current through this is I, let us say. Okay, so in this circuit we have to find out the effective input resistance of this circuit. The input resistance means voltage divided by the current. What's the value of Vi divided by I, which is the value of input resistance of this circuit. You can apply Kirchhoff's laws and try to find out the value of V0 in terms of Vi, and hence you can derive at this value. Okay, so to people who want to solve this problem, what you can do is you can note down the question and just 2 steps. Okay, first step will be find the value of V0 in terms of Vi. Okay, and the second step is do KCL. Okay, after you apply KCL you will arrive at an equation and you have to substitute this in this and hence find out Vi divided by I, which is the input resistance of this circuit. You can pause this video here and then solve this problem, then try to check if I am right. If you have any difficulties in understanding, you can type that down in the comment section. You can also mail to learningtoengineer@gmail.com. Okay, so now let's solve this problem. Okay, let's first find out V0 in terms of Vi. So at this node, as usual, by virtual ground concept, 0 ampere is flowing into the inverting terminal. So this current directly enters into 3R and hence these both are in series connection. Okay, yeah. So what is the value of this current? It will be 0 minus V0 divided by 3R, right? This is the value of this feedback resistor's current. This will be nothing but the value of the current through this resistor R, which is nothing but Vi minus 0 divided by R. So let's cancel R. So what is V0? V0 will be equal to minus 3Vi. Okay, done. V0 is equal to minus 3Vi. We have solved one half of the problem. The second step is you have to find out the current that is through this path plus the current through this path will give you the value of I, right? So what is I? Okay, this is the first step. Okay, I am doing the second step here. The value of the current I will be this current plus this current. Okay, so what is the value of this current? It is going to be Vi minus V0 divided by 2R. Plus the value of this current, Vi minus 0 divided by R. Right? We know the value of V0 in terms of Vi, right? So I is equal to Vi minus of minus plus 3Vi divided by 2R plus Vi divided by R. Okay, so 3 plus 1 is 4, 4 divided by 2 is 2, so this is equal to 2Vi by R plus Vi by R, which is equal to 3 times Vi by R. So if you rearrange the terms and find out R, what is R? So this implies that the resistance is equal to 3 times Vi by, the input resistance will be R divided by 3. Vi by I is equal to R divided by 3. Okay, this is the input resistance of the circuit. So thanks for watching. If you have any tricky problems in this concept, or if you want some more clarity in any of these concepts, you can write to me at learningtoengineer@gmail.com. And if you also want to be featuring any other, if you also want some other topic to be featured in this channel, you can let me know in the comments, or you can simply write to me as well. Okay, so from the next video, we are going to see OPAMP as a non-ideal device. We are going to see the OPAMP as a practical guy, which is not ideal. So there will be slightly change in the concept of virtual ground. That is, we can't apply the concept of virtual ground anymore because there will be a small leakage current that is entering into the terminals of an op-amp. So it is not exactly zero as we did so far. So from the next videos of this playlist, we will be seeing the practical concepts of an op-amp. If in a problem you find that LM741 IC is used for this circuit, so find out the value of this from what is given. So when you are finding the word LM741 or any specific model of op-amp that is given to you, you should understand that this is a practical op-amp and you cannot apply all the ideal op-amp characteristics in this problem. Okay, so let us see the practical aspects of an operational amplifier. We will also look at the data sheet of an op-amp and understand the different parameters that is associated with it. So thanks for watching and do subscribe to my channel in case you want to watch this video, and there will be a notification on your mobile phone once I publish my next video on op-amp. Thank you.